Welcome back to the channel. If you have been following the automotive industry for the last few years, you might have noticed a strange and uncomfortable silence coming from Europe for the better part of a decade. We were sold a very specific story by the politicians in Brussels and the executives in Detroit. They told us that the internal combustion engine was dead, a dinosaur walking towards its own extinction. They promised that by 2026, where we stand today, the transition to electric trucks would be inevitable, and that investing in diesel technology was a waste of money. Major Western manufacturers, the titans like Scania, Volvo, and Cummins, spent billions dismantling their legendary engine development teams to chase the electric dream. But while the West was busy dismantling its own heritage, something else was happening in the East. While we were arguing about charging cables that don't reach the Australian Outback, Chinese engineers were doing something far more dangerous to the status quo. First, they shocked us with a petrol engine achieving 48% thermal efficiency. That alone should have been a wake-up call, but the real blow came quietly back in early 2024. Do you remember where you were in April 2024? That was the moment Weichai Power, or Y, stood on a stage and dropped a bomb on the laws of physics. They announced the world's first diesel engine with a certified thermal efficiency of 53.09%. The reaction from the Western media was predictable. They called it a lab experiment, claiming it might run on a test bench but could never be mass-produced, dismissing it as propaganda. Well, it is now January 2026, the dust has settled, and we need to have a very serious conversation about what has happened in the shadows since then, because Y didn't just hang a certificate on the wall, they went to work, they took that lab experiment, and industrialized it into the most terrifyingly efficient powertrain the world has ever seen. Today, we are going to examine the maturity of this technology. We will analyze how Chinese engineers spent the last 2 years perfecting the impossible engine while much of the West slept. We will break down exactly how this machine works, why it is the silver bullet for the rugged landscapes of Australia and the United States, and why putting this technology into a pickup truck would be game over for the Ford Ranger and the Toyota Hilux. If you want to understand the machines that actually run the world, subscribe now. Let's open the bonnet. To understand the gravity of this achievement, you must first understand the invisible wall that engineers have been banging their heads against for a century. The diesel cycle is efficient, it is the backbone of the global economy, but for decades the industry standard for a heavy-duty truck engine, like the Scania DC13, the Volvo D13, or the Cummins X15, hovered around the 46% mark. Getting to 46% was hard. Getting to 47% cost billions in research and development. Why? Because of the second law of thermodynamics, you are fighting entropy. In a standard engine, more than half of the energy in expensive diesel fuel is wasted exiting the exhaust pipe as heat radiating from the engine block or lost to mechanical friction. When Y announced they had broken 50% in 2020, the industry was skeptical. When they hit 51% and 52%, people got nervous, but hitting 53.09% is not just an improvement, it is a generational leap. To put this in perspective for the layman, the difference between a 46% efficient engine and a 53% efficient engine is not simply a 7% fee increase. That is not how the math works in logistics. It represents a reduction in fuel consumption of approximately 14%. In a low-margin industry like logistics, where fuel is a primary operational cost, 14% is the difference between bankruptcy and market dominance. While the West was busy designing Euro 7 filters to manage emissions, often at the cost of efficiency and complexity, China was redesigning the combustion process itself. They weren't trying to patch an old design, they were perfecting the physics of the explosion. And now, in 2026, that difference is no longer theoretical, it is on the road. The technical breakdown, how the impossible was achieved. Many of you watching this channel are engineers or gearheads, so let's respect your intelligence and get technical. First, let's talk about high-expansion combustion technology. This is the heart of the beast. In a normal engine, a significant amount of energy is lost because the combustion event isn't perfectly timed with the piston movement. Wise engineers completely redesigned the bore-to-stroke ratio and the piston bowl geometry. They created a system where the burning diesel pushes the piston down for a critical fraction of a millisecond longer, extracting every last joule of kinetic energy before the exhaust valve opens. They are, in essence, squeezing the explosion dry. Second, we have the ultra-high-pressure fuel injection system. To burn diesel efficiently, you need maximum surface area. You need to turn a liquid into a gas instantly. Y pushed fuel injection pressures to staggering levels, pressures that could metaphorically cut through steel. This atomizes the fuel into a cloud of microscopic droplets, ensuring a near instantaneous and complete burn. So, a complete burn means less soot, less unburnt hydrocarbon waste, and honestly, significantly more useful power extracted from every single drop of fuel. This technology really puts them comfortably ahead of the standard high-pressure common rail systems used in Europe. Third is the advanced mixed-flow turbocharging. Turbo lag and exhaust back pressure are, well, the perennial enemies of efficiency. Standard fixed geometry turbos are always a compromise. Why implemented a sophisticated mixed-flow turbine design? Just think of it as the difference between breathing through a narrow straw and breathing through a wide snorkel. This turbo design dramatically reduces pumping losses, the energy the engine must expend just to suck in air and push out exhaust. By optimizing the aerodynamics of the impeller, they feed the engine with dense, oxygen-rich air without forcing the pistons to work harder against vacuum or pressure. Fourth, and perhaps most crucially, is the comprehensive friction reduction. This is the unsexy part that makes all the difference. They redesigned the crankshaft journals, piston skirts, and valve train, employing low-friction coatings derived from aerospace technology. Every joule of energy lost to friction is a joule that never reaches the wheels. Why reduced mechanical losses to a level previously thought impossible for a heavy-duty, durable engine block? So, this holistic approach, where every subsystem is optimized in concert, is actually what enabled the breach of the 53% barrier. The hybrid endgame. Why diesel isn't dying, it's evolving. Now, here's where the story gets, profoundly interesting for 2026. Some of you will rightly say, but diesel is dying, everything is going electric or hybrid. You are correct, and that is precisely why this engine is so strategically dangerous. So, we know that Chinese companies like BYD are dominating with their DMO hybrid platform, and Great Wall Motor has its Hi4T system. These are series or parallel hybrids where the internal combustion engine acts primarily as a highly efficient generator for the battery pack. Now, just imagine replacing the current petrol generators in those hybrids with a scaled-down version of this 53% efficient diesel technology. An electric motor is like about 90 to 95% efficient. If your onboard power source, the generator, jumps from 40% efficiency, which is typical for gasoline, to 53% efficiency with advanced diesel, you have just created the ultimate long-range machine. We are talking about a vehicle that could, in theory, achieve a 2,000-kilometer range on a single tank of fuel. This is really the definitive endgame for range anxiety. This technology proves that the advanced combustion engine isn't the enemy of the electric vehicle. Honestly, it's the ultimate range-extending partner. The Chinese understood this synergy. That's why they kept developing diesel with ferocious intensity while the West largely stopped. They were playing multi-dimensional chess. Let's bring this down to the tarmac. Why does a bloke in Western Australia or a trucker in Texas care about a Chinese engine record from 2024? Because geography dictates technology. In the UK and Europe, distances between major hubs are relatively short, and charging infrastructure is densely packed. But look at the map of Australia. You have road trains hauling 100 tons across the Nullarbor Plain. Temperatures hit 45 degrees Celsius, or 113 Fahrenheit. The dust is relentless and destroys everything. Reliable high-power charging infrastructure simply does not exist at the required scale. If you put a battery electric truck on a road train route, the battery weight alone would consume a catastrophic portion of your legal payload capacity. It is physically and economically unviable. This is where the YWP-13H platform shines with brutal